Hello friends, welcome back to our channel. This is another video session on Verilog course where we discuss practical lab sessions using SDL Bits website. If you have not gone through my previous video sessions, please go through them where I have taught how to create the login and we have done few examples also. In this video, we will directly start the practical session. And now without wasting much time, let us get started. After opening this website, you have to go to this problem set, browse problem set. In our previous session, we have covered the module definition where we covered getting started and output 0. But now we will cover this simple wire problem statement. Friends, let us see what is a problem statement. In the problem statement, we have to design a module with the name top_module. It has one input in and one output out. And the behavior of the module should be input should directly pass to output. It is just a wire. So what type of Verilog statements will help us to implement this type of circuitry? Let us see it. So firstly, they have declared module and its name is top_module. Input is in, output is out. They have used Verilog 2001 structure. We have discussed in our previous video. And now I will tell you what type of statement we have to write to implement this top module. Because we want that input should pass to output always. Whenever there is a change in the input, it should appear at the output. So here Verilog provides assign statement. Assign output is equal to input. That's all. Now let us submit it and see the results. Status is success. This is the input. This is the output which is exactly matching. And this is the reference output. There is no mismatch. So we are successful. Now let us see the next problem statement. For the next problem statement, we will click on this wire 4. Okay, what is in this problem statement? In this we have to design a module. It has 3 inputs A, B, C. And 4 outputs W, X, Y, Z, and the name of this problem statement is wire 4. So output is W, X, Y, Z, 4 outputs. How is the behavior of this module? A is directly passing to W, B is passing to X and Y, and C is passing to Z. So this is the module definition as per Verilog 2001. Input is ABC, output is WXYZ. So here module definition is only given. So we have to write the statements. So Verilog, as we mentioned previously, we have assign statement given by Verilog language. Let us write it. Assign W is equal to A. Let us copy this, paste it. Now X is equal to B, then copy it, paste it. Y is equal to B again, then assign Z is equal to C. Let us submit it, see the results. Status is successful. These are the inputs given by default test bench by this website. These W, X, Y, Z are our outputs and these are reference outputs which are exactly matching. There is no mismatch between them. So we are successful. Now let us see the next problem statement. Just scroll towards the bottom of this page, press on this NOT gate. Now the next problem statement is we have to implement a module with the name top module. It has one input in and one output out, but we have to implement a combination logic which is nothing but a simple NOT gate. Let us see how we implement it using Verilog language. So they have given the module definition. Input is in, output is out, but we have to write the statements, Verilog statements to implement the desired design. So again we have to do assign out is equal to not of in. Now let us submit it. Let us see the results. Result is again successful. This is the input given by the website. This is our output. This is reference output, and mismatch is nowhere. Friends, one more thing to implement this NOT gate, I'm going to tell you. Let us go to the design again. And here I type this tilde. But instead of this tilde, I will type negation operator here. So let me submit it. Let us see the results. Results are again successful. In output is matching with the reference design. There is no mismatch. That means we have implemented the NOT gate with the help of two operators, tilde operator and negation operator. If you want to know the difference between these two operators in Verilog, I have created a separate video and I will share its link in the description section as well as in the I-bar section. You can go through it. But here I don't want to break the flow. Friends, just to want the video length short, I'm going to end this video session here only. I hope that this video will be quite informative for all of you. If you also like this video, please press the like button and you can share your feedback in the comment section. And in future also we are going to create many such videos. So to be aligned with our channel, don't forget to subscribe it and press the bell icon to get the notification of all the upcoming videos. Thank you so much for watching and your time.